Hi everyone, this is Rishi and I hope you're all doing great. So today let us go over some important topics for your upcoming assignment. I think by this time we all know that algorithms are of two types. One is iterative algorithms and the second one is called recursive algorithms. So one thing we can all agree on is that an iterative algorithm is something that has a loop in it. Whether it be a while loop or a for loop, it doesn't matter, but something with a loop and an iterative variable is called basically an iterative algorithm. So let us go over some important characteristics of this iterative algorithms. So all the iterative algorithms have three conditions essentially. The first one is called the break condition, second one loop invariant, and the third one is called post condition. So let us go in depth into each of these three topics, but first of all, let me just give a brief introduction. So a break condition is something which will determine when the loop will break. So when the break condition is true, the loop will terminate. So that is what a break condition is. The loop invariant is a condition which holds true at the beginning and end of each iteration. So the loop invariant is a condition which holds true at the beginning and end of each iteration. The post condition is a condition which holds true after the whole algorithm has finished executing. So the post condition is something which we are trying to achieve. So let us come back to this algorithm and start. So right off the bat, we can see that this is just a basic array and we are trying to add all the elements of this array. That is what this algorithm does. So what does it have? It has a precondition, a post condition, and initialization section and the loop. So first of all, what we need to understand in the precondition is that A is the starting index of the array and B is the ending index of the array. So the precondition says that A is less than or equal to B plus 1. A precondition is something which needs to be true at the beginning of the iteration. So we have the precondition A is equal to 0 and B is equal to 6, and obviously 0 is less than or equal to 6. So we have the precondition which is true. Now let's move on to the post condition. From the post condition, we can say that for all indices A through B, the sum of the elements in this array will be equal to the variable sum. And we'll look into it more carefully later, but let's just come down. So we have initialized the variables. I is the iterator here and A is the first initial index of the array. So I is equal to A, and sum at the beginning of this, the variable sum is initialized to 0 so that it doesn't have any value. And while we loop through the array, we will add the values and increment sum. So look what we are doing here. While I is not equal to B plus 1, because B is the last index of the array, and if the iterator variable goes beyond the value of B, we know that we'll get an array out of bounds exception. So while I is not equal to B plus 1, which means that the maximum value of I should be B only, do sum is equal to sum plus A of I. So when the value of I is equal to 0, we are going to add sum is equal to sum plus how much? 1. So we know that the sum is equal to 0 at the start. So after that, sum will become sum is equal to 1 after the first iteration. After we increment sum, we are incrementing the value of I. So as we move through the index through the variable I, we will increment the value sum, the variable sum, by adding all the values in the array. So when will this loop terminate? The loop will terminate when the value of I becomes equal to B plus 1. That is when the I value comes here, 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 and so on. And after it reaches this value, this will be the last value. And after this, when I value reaches B plus 1, reaches b plus 1, this loop will terminate and finally exit. The condition which, when it becomes true, terminates the loop is called the break condition. So what is the break condition here? It is I is equal to b plus 1. And now let us look at what exactly is loop invariant. So what is basically our aim here? We are trying to add all the values of this array and get the total sum. So we have initialized the variable sum to 0. So what did we tell about the loop invariant? It has to be true at the beginning and end of each iteration. And it depends upon what we are trying to achieve. We are trying to get the sum of all the values in this array into the variable sum. So after the first iteration, when the value of I is equal to 0, what will be the value of sum? Sum is equal to sum plus a of I, which is equal to a of 0, right? So this will be equal to 1. Sum will be is equal to 0 plus 1, which is equal to 1. So after the first iteration, the value of sum is equal to 1. Now the value of I will be incremented when the first iteration is done, and then we are going to the second iteration. At the beginning of the iteration, how many values have we passed? We have only passed to the first index. So until then we have only gone through one element, and the sum holds the sum of all the variables till the first index, which is 1. Now that is true at the beginning of the second iteration, right? And now when we increment the value of I to 1, we get sum is equal to sum plus a of I again, and we will say that, which is here, a of 1 is equal to 2. So we will get 1 plus 2 is equal to 3. So now at the end of the second iteration, the I value is equal to 1. We have gone through two elements in the array, and now by the end of this iteration, we have summed the values of the first index and the second index. 1 plus 2 is equal to 3, and we put them into the variable sum. So what can we say? As we increment the I value, the variable sum is holding the sum of all the elements from A to I, where A is equal to 0 and I in this case is 2. So we can say that here the loop invariant is for all indices I such that I belongs to the array A from A to J. Here the J index represents till which position we have reached while iterating. Okay, A to J. The variable sum will hold the sum of all the indices from I is equal to A to J A of I. So this will be the loop invariant. Let me clear up some of this mess, and so let us finally go over what is post condition. I think we have already defined what the post condition is in the above. So as we loop through the array from A to B, the variable sum should hold the addition of all the values in the array. So we have 1, 2, 3, 4, 5, 6, 7. So let us say here, when the value of I is equal to 0, S is equal to what? 1. So when it is equal to 1, the value of S was equal to 3. When it goes to 2, the value of S is equal to 6. When I is equal to 3, the value of S is equal to 10. And when I is equal to 4, the value is equal to 15. And when I is equal to 5, the value goes up to 21. And when I is finally equal to 6, the value of sum will equal 28. And now if we exceed here, when I becomes 7, we know that I is becoming equal to b plus 1. So we are achieving the break condition here. So by the end, when we have exceeded the limit, the sum was equal to 28 and it had the addition of all the values in the array. So what can we say? At the post condition, the break condition was true and the loop invariant was also true. So we can achieve post condition when the break condition and the loop invariant both are true. So what can we define the post condition finally as? Sum is equal to I is equal to A to B so this is the post condition. And we have to remember that the post condition can only be achieved along with break condition and loop invariant. So let me write down properly and explain once again what are the three conditions. The first one is the break condition, which when it becomes true will terminate the loop. So we have here already that I is not equal to b plus 1. So when will the loop terminate? It will terminate when I value becomes equal to b plus 1. And that is happening because when I value reaches b plus 1, when it reaches here, it is exceeding the maximum limit. So the break condition will become equal to A is equal to b plus 1. You can get this break condition from the while loop here. And when we go to the loop invariant, for all indices I such that I belongs to the array A from A to an index j, the variable sum will hold all the values of the array from A to j. This is the loop invariant. The loop invariant is true at each and every beginning and ending of every iteration. You have to remember that. And coming finally to post condition. When the break condition is true and we also have the loop invariant as true, which means the loop has terminated, and by the time the loop terminated, the variable sum is holding the addition of all the values from A to B, then we can say that the post condition has been achieved, which is sum is equal to addition of all the values from A to B. So that's it, and I hope you got a clarity about what is break condition, what is loop invariant, and what is a post condition. And if you still have any doubts, you can always come and contact me during the TA hours. Thank you.